now we're going to talk about the multiplication rule and conditional probability. So I basically put two sections into one, and you'll see why is, that portion. They're very similar to one another as well. Okay, so in the first part, we're going to talk about the and probability. So what's the probability of one and the other one happening at the same time? Different than the or, right? This is this or this happening. Now this one, I want both of them happen at the same time. So we talked about this last time, this concept, but we're going to define it far more in detail in this section here. So first major definition is something called independent events. So independent events are two events, A and B are independent if the outcomes of event A does not affect the outcomes of event B, meaning one does not affect the other one. Okay. An example of that would be throwing dice and flipping a coin, right? For example, you getting a 5 on the rolling a dice has nothing to do with you getting the heads on flipping a coin, right? So it's literally nothing to do with one. It does not affect each other. Okay. So when we have two events do not affect each other, or in other words, being independent, we have our equation for the and probability. So given two or more events A and B, the probability of event A and the probability of event B occurring / happening is equal to the multiplication of each individual probability. Now, we talked about this last time, right? There's another equation for that, but unfortunately, that uses this, right? And most of the time, we will not know this exact answer, the probability of A or B, because we just subtracted. So we cannot use that portion. We have to use this equation to find the actual probability of an and itself. Given, again, two different events, we want the and portion. So hence why it's called the multiplication rule, because we literally multiply. So or means addition, and means multiplication becomes. Again, a key thing is if the events are independent of each other. Okay? So let's do an example so you can see how this will work out itself. Okay? So example says, given a coin and a 6-sided dice, find the probability of getting heads and rolling a 5. Okay, so event F, I'll call it event F, is getting the heads, and event G is getting a rolling a 5. So the question is, are the two events independent? Meaning, does me rolling a head, getting a heads, have anything to do with me rolling a 5? And no, right, it has nothing to do with it, so they are independent, yes. They do not affect one another. So therefore, the probability of A and B is the multiplication of each individual together. So therefore, the probability of A, well, it's probably getting heads. That's 1 out of 2 times. The probability of getting a rolling a 5, so that's 1 out of 6, right? So this becomes 1 out of 12. Okay, so we just multiply across, right? Remember, fractions you multiply across, so that gives us a grand total of 0.083 as our answer. Okay. Now, when it comes to the and, before we go any further, there's a couple of things I do want to go into play. What I want to do is, well, the first thing is the word and doesn't always have to mean that bad. So we'll say this. So when it comes to the and probability, I don't have to say just and. So obviously I can say this and this happening. Another way to write and is any deviations of that. So for example, both mean using the and rule. Together means you're using the and probability. All, it means the and rule. Everything means it. See, what's another one? I think all of them is another phrase I use or the book uses. So all of them. The main ones is both, all, is when it comes to it. And then when it comes to cards, I believe one very particular one is in a row. Right, so all of these portions mean and, okay? When it comes to or, there's only one word, or. So I have to say this or this. However, the and probability, I can use any of these, and it implies using the and, so you're multiplying itself. So you gotta have to recognize it in the question what these phrases represent and which one you're gonna be using. So again, it's a hard line, right, when it comes to it. There's only one word for or. I cannot give you anything else. But when it comes to the and probability, there's multiple ones to relate back to the and. Okay? All right, so now that we have that down, let's try some couple questions out. And let's do question 1 at the very bottom here. Okay. So question 1 says, using the deck of cards and selecting 2 cards, so we're picking 2 cards at random, find A, the probability of getting an ace on the first try and a king on the second try with replacements. So with replacements meaning you put the card back in the deck before you take the second card. So right, shuffle the deck, you pick one card, you put it back in, and we keep going from there, right, when it comes to it. Okay, so we have 2 stats. So let's say A and B. So A is getting an ace. Yep, getting an ace. And then B is getting a king. Right, so since it's and, right? And, so it's multiplication. So I'm multiplying, so the probability of A, well, how many aces are there? There's 4 out of 52 aces. And how many kings? There's also 4 out of 52 kings. So there we go, we multiply. So multiplying these out, and we get what? Get approximately 0.006. Okay. So let's try some more. Flip the page. Let's go to B here. We probably only getting an 8 on the first try and a 4 of hearts on the second try with replacement. So again, with that replacement portion. So again, this is my event A. This is my event B. So probability of A. So again, it's and, right? So it's multiplying. So the probability of event A is 1. So I start 4 out of 52 cards are 8s, right? Times the probability of getting 4 of hearts. There's only 1 4 of hearts out of 52 cards. So this time we multiply across. And we get approximately 0.001 as our probability to 3 decimal places. Okay. All right, so now let's go to C. So C says the probability of getting a queen, so this was queen of spades on your first try and an ace on your second try. Now this says without replacements. So meaning you don't put the card back in the deck before you take the second card. Okay, so meaning I get the queen of hearts and I put it back on the table and then I get my second card. Okay. All right, so A is queen of spades and B is just an ace. Okay. Right, so again it's multiplying, right? So it's and. So the probability of A, let's see, so how many queen of spades are there? There's only one queen of spades. Okay. Now this is what we're thinking about, right? Next one is aces. So there's 4 aces. But how many cards are left over? Now it says without replacements, meaning you don't put the card back in the deck when you take your second try. So I have my deck of cards. I have a queen of spades in my hand, and I put it to the side. I don't put it back in the deck, which means how many total cards do I have left over? It should be a total of 51 left over, right? Does that make sense? There's one less card because one's on the table, not back in the deck. So that's interesting, right? It says without replacements. So this changes a little bit. So now this would be 1 over 52 times 4 out of 51 this time. And this gives you about 0.002. Okay. So that's interesting. This is without replacements. So let's try another example kind of like that. So D down here. So the probability of getting an 8 on the first try and then 4 hearts on the second try, again, without replacements. So same concept that we did above, right? It came to it. All right, so this is A, this is B. And again, and was multiplying. So we did this earlier, right? So there's 4 8s out of 52. There's only 4 of hearts. But again, how many total cards left over? Only 51, right? Now, a lot of you guys may think, well, why not 48? Now, if you do 48, that means you took 4 cards out. How is that possible? I only want 2 cards, right? 2 cards in my hand. So if you deduct this by 4, that means you have 4 cards in your hand. But I only want 2 cards. This is 1 card, 2 cards, right? So you don't only subtract the top, you subtract how many cards you took out. Remember, this basic probability means this how many cards you have total in your outcomes, right? So be very wary of that mistake a lot of people use when it comes to it. And there we go, multiplying these out, and that gives you your probability, which is the same as that one there. Okay. So because of this, without replacement stuff is pretty interesting, we may have to redefine our events. So when two events are not independent, so meaning they do affect each other, so they depend on one another, therefore we have to define something else. Okay, and this is our new equation when we have dependent events. So one depends on the other. It's the probability of A, so that's still the same, times, now this is kind of weird, right? So we're going to define a new term here. This means the probability of event B happening given event A has already happened. Now, all we're doing is defining exactly what this number comes from. Notice, right? If I go back over here, this portion right here is this number here. What this is saying is this probability is the probability of getting a 8 on my first try. Oh, sorry. This is the probability of getting a 4 hearts on my second try, given that I already got an 8 on my first try. Does that make sense? That's why we deducted by 1, because we're assuming we took out an 8 already. That means there's one less card in the deck. So all we're doing is defining what this number represents in mathematics. That's it. Okay, and we're just giving it a notation. So this is the probability of given stuff. So given the first event already happened, and now remember, I can go from a chain down the line when it comes to it. Okay, so for instance, and you'll see it a little later, I can break it down to go farther down. So for example, here, let's suppose now I wanted to find the probability of, let's say, 3 aces in a row. So I want to find the probability of 3 aces in a row. So 3 cards when I get the cards out. Now, notice in a row, it's right here, is a deviation for and. So you know this is the and probability, right? So I'm multiplying. Okay, so what's the probability of getting 1 ace? There's 4 out of 52. Okay, right? So without replacements. So therefore, I have 1 ace on the outside. How many more aces are left over? Hopefully 3 left over, correct? There's 1 already outside because I'm assuming I took that out. Also, how many total cards are left over? 51, right? Because there's 1 ace missing. Okay, that's my first card. So let's say on my first hand, right? My first hand. This is my second in my hand, and I want my third in my hand. Well, I already took 2 cards out, right? 2 aces out. So how many aces are left over? 2 of them. And how many total cards are left over if I take out 2 cards? 50, right? So notice now, it doesn't always have to be the bottom that gets deducted. It could be the top gets deducted as well. It all depends on what the question is actually asking, okay?